Hi, my name is Andres Quiroz Usteño, and this is Lab 1 from CSE120.
Hello everybody, hello graders. I'm going to be explaining my project. The first thing we did was the 1-bit half adder. So we got two buttons, A and B. If you press the A button, the sum turns on because if it's just one, then it's just one. But if two of them, the carry turns on because 1 plus 1 it can't fit, so it goes into the next bit. This is what it looks like. So I can see we got 4 lines indicating each value, two inputs and 2 outputs, I guess. So in here we got 1 input turned on, and we got the sum value turned on, or they're both 1. Over here they got this one turns on, off, and then this one turns on. So still 1 value, so the sum is 1. But here, 2 of them turn on. Now the carry turns on because you can't have 2 bits adding, like you can't have a 2 in binary, right? It's 0, 0, 1. So let's go to the 4-bit one. So let's see how this works. There's basically a lot of them together because I had to import that component into a new one. So we start here with 0, and again, so it takes the other one. So 2 outputs, it could be either a sum or carry. So if it's 1, 1, and then if you press the carry input carry, then it would either turn this one on or turn this carry input to the next one, and then it goes again. Hopefully you can see my mouse, but then it carries off again until you can either the outputs are Y, which is a 4-bit output, and the carry. So see the waveform. So as you can see, the red line indicates where it is. So right now it's B because it's in the 11th row, but it goes incrementing 1 by 1. That's the test. Into the 1 by 1. And you can see the waveform reflects this till it's F, and then carry out because it has to add 1 to 15, which you can't because it's hexadecimal is 16, but includes 0. So 15 is the end. That's why you get a carry out there. Or yeah, CRY stands for carry out. Now I don't know how long this needs to be, but okay. So now we're doing the full bit adder. A, B, and not. So how does this work? Okay, so the diagram, it's explaining that right here. The carry out is 1, sum is 1. So yeah. Anyway, let's continue. So this one is like we did before. It's a bunch of addition together, 4-bit adders. And then over here we can see the tests I made. So in here it's adding 2 positive numbers, or yeah, 1 and 1. Here's 2 positive numbers again, 1, 3. Yeah. Over here there's 2 negative numbers. And you can see the stimulus I did. Both A and B are 0. Checks if what happens if they're all 0 and this passed. If all of them are 1, it outputs 2. 2 positive numbers, it outputs 6. 2 negative numbers, which is -7. -7 is -14. Minus plus. And the carry out, because you have to invert the -7 into its complements. Positive and negative, 7 minus 14 equals 6 and has a carry out. 1 test with carry input, carry in, sorry. So 1, 1. So you see there's 2 1s here, like 1 plus 1. And if we do a carry in, that's 2, right? But if we do a carry in, it'll be 3. And this is a carry in input. So put a 1 here. Some of the produce a carry out. 5 plus 5 is 10. But in order to do 10, you need to do a carry out. So that is a 2 here, and it's A. So that was a carry out and an overflow. So that passed. I'm forgetting one, but there is one that I also did that I should add. But yeah, orbit orbit stimulus. So I am missing some overflow, right? Carry out, carry an overflow. I'm missing the carry overflow one. So let's talk about that. This pass. So what is this doing? So 5 loses 10 and it is overflow. I don't think I did that. 5 loses 10 and it was a carry out. So I did both of them for the testing, but yeah, that is my project. Thank you for watching.